Hello, Rasha and Rishit and Rohan. Are you there?
Yes, I'm here.
How? Hi, hello.
Hello.
How are you? Are you ready for your presentation?
Surely.
Excited? That's good. What are you gonna talk about today in this presentation?
Sure. Hi, and today we'll be talking about our project. We'll be showcasing our project, um, uh, which is called Plant AI. And we have been working on this project for quite some while, and we have been using Azure and Azure machine learning, a lot of Azure web apps, a lot of cool stuff from Azure. We are quite honored to have a chance to participate in the project showcase and show our project. Uh, First off, uh, if you want to know a bit about us, hi, I'm Rishit, and I worked on a lot of the machine learning aspect of this project. I'm also a high school student, and you might have seen me earlier today in one of those talks, one of those panel discussions, if you were there that time.
Hey, Rishit, before you go any further, I think there might be something covering the first half of your screen, like the main part of your screen.
Ah, uh, Better now?
Yeah.
Yes, looks awesome. Thank you.
Thanks for bringing that up. Rucha, would you like to go on?
Sure. So, hello everyone. I'm Rucha Yagnik. I'm a Gold Student Ambassador. I'm a graduate student at University of Southern California. For this project, I basically worked as a React developer, and that's my contribution to this project. I had an awesome team to work with, so I'd have Rishabh go on next.
Thanks, Lucia. All right, so I am the UI UX designer of our project, right from the starting, how it is going to work, from how it is going to look. I managed all of it, and it was great working with Rishit and Ruta. And this is just the beginning. We have lots of things planned ahead, so I'm pretty excited about that.
Next up, probably Rishabh could go on and start talking about the project.
Sure, perfect. All right, so let's first get into the motivation and why we decided to create Plant AI in the first place. So it was a really normal day on the internet, and we were just browsing through our socials when we came across a really disturbing headline. And the headline, which was printed on the India's biggest newspaper, which was Times of India, and it said that a farmer killed his two kids and wife for because of death. So, and that was a huge shock for all of us reading that headline because, and it's not something really old. It just happened earlier this year, which was really, really shocking for all of us. So, to actually see what's happening behind the scenes, actually see what's going on, we decided to do some research. And we realized that it's not just our country. There are a lot of countries which have been going through this problem, and a lot of crops are being destroyed. But what was the issue? Why it was actually happening? We found out that it was nothing but the diseases which are affecting the crops and hence causing the issues which we can see in the graph right now. Coming to the next thing, we are passion driven individuals who love to solve problems, it was a great opportunity for us to come together, to form a team, and to do and to create something which can actually help people solve this problem. But now, since we talked about the motivation behind and a little bit a background story of the everything that happened before. Let's talk about what's the actual problem and summarize it in a few points. So coming to that, so the first problem was the diseases and deficiencies. And as we all know, it's not easy to find out. If you had plants before, so you know what I'm talking about. You can't just look at the plant and you can't just find out what's causing the issues.
Sorry for that. I think I stumbled upon something and missed a couple of slides over there. Sorry for that. Please go on, Rishabh. I'll read your slide. Yeah, please go on.
Sure. Okay. Digging a little more into the problem, we found out that in just India, around 67% crops, that is more than the half, are getting destroyed every single year. And that's like, and when you think about the bigger picture, it's like 2 in 5 crop yields around the world are usually affected and get destroyed, and they never come to your plate. So, and that's not reasonable. If you think about it, it's actually a massive scale and it's happening right now. The problem was actually huge. So, but the solution was very much possible. We just wanted to help people to find out why it is happening and what they can do about it right away. So one thing which we realized that mostly all the farmers around the world have access to smartphones with some internet connectivity, which was a breaking point for all of us. And we decided to bring our product in a form that can be used for everyone, and that was the web. So coming to the so what we actually did. So we basically created a AI model which is capable of diagnosing diseases from plant images early. So you just have to point your camera into it and it will tell you what are the things which are wrong with the plant, and there you go. Coming up, we are not, and that's not all. We also provide actionable ways to solve the diseases. So you don't have to visit a laboratory, you don't have to call an expert to find out what's wrong with the plant and how you can treat it. You can do that right from the app. Next up, since not every cure can fit a single plant, we provide various alternative ways also to find out what works best for your plant and how you can treat it right from the app. Coming to the next, but the most important point was that a lot of people, especially in India, don't have access to a stable internet connection, which was really something we needed to focus on, because what's the use if the app is not working on your field? So we also worked on bringing offline support and PWA support to the app, which will definitely help us people get the job done no matter where they are, no matter about internet connections. So coming forward, this is a screenshot of our app, and this is basically how you have to select and how this works. So Rishit will be coming over and giving you a short demo of how the entire app works.
Sure. So let me reshare my screen, and this time I'll show around a live demo of our app, and I'll try to show how well our app can work in action. So we just talked about how we thought of building the app. So I think a nice thing to top this off would be to probably show our app live in action. So while we keep this up, so by the way, you might think this is a website, and well, it's a PWA, so it works offline as well. And we'll soon talk about the parts, how we make it accessible to people with low internet connection, or how we make it accessible to, since most of the crop growers do not have super advanced smartphones. We'll soon talk about that. But what I wanted to do is, in our research, we also we also wanted to support a large number of plant species. So we ended up supporting 38 different plant species and diseases. So I want to show you a live demo of one of them. So I'll just take a very common disease, which is called apple seed or rust. So this is a really common disease, which, as you might have guessed, happens in apples. So I'll just go on to Google Images, try taking an image of this, uh, just an image from Google Images, and see if our app can work well with this. So yeah, that's what my goal is. So yeah, this is also the website. It works on desktop as well, though most of what we showed you was about how well it works on mobile devices. So let me try putting this in. The image we just got from Google Images. I just searched up cedar apple rust, and this was a real life plant image, what we just took from Google Images. And it turns out that our model was able to, in just a couple of seconds, and all of this was offline. All of the machine learning ran on the device. So our model was able to tell me correctly that what kind of disease this is. It was a cedar apple rust, right? As you were talking about. It also correctly identifies the species, apple. So this is super helpful because while we were researching, we also found out that there might be a same disease. So I'll give you an example that came up extensively during our research. The disease was called scab. So the scab disease can happen in apples as well as in grapes. But well, how do you solve that? Which is what we also wanted to do, right? We also wanted to provide actionable ways to solve it. So what we ended up doing is seeing this example of apple scab and grape scab. Both of them are the exact same diseases, but solving them requires altogether different strategies. So our AI model also ends up predicting or trying to predict the species. So our problem would be better termed as hierarchical image classification, if you are interested in machine learning. So that is what we do over here. We first try to predict the species as well. So with the species in hand, we can give far better prognosis of how to solve the disease. That was also one of the things which we really wanted to do. Gives not only actionable ways to solve it, but specific ways to solve it, because solving the same disease in different species often requires completely different strategies. So that is something we are also really proud of, not just disease and not just identifying diseases. And since we are already beta testing our application, we not only have this nice interface which crop growers can start using, but we also have APIs for the machine learning model, for the chunky machine learning model we built, so others can use it as well. And in our beta testing, we also figured out that this would approximately decrease plant losses by as low as 25% in our community, India. So from 60, we could easily go from 67% plant losses in India to 25% plant losses in India, which I think is a really sizable gain. We also wanted to talk about existing solutions and how our AI model or how our project as a whole is different from them. And one existing solution I think a lot of you might be familiar with was called CropNet. There's a really cool research paper about this as well. And this was deployed by Google, a really nice project. And this does wonders, but well, this only works on cassava plants. So cassava is a really dominant species in Africa, a really dominant species of plant grown in Africa. But well, this just works for cassava plant. And we wanted to support a lot more species, a lot more diseases than just supporting cassava plant. So we end up supporting over 38 diseases and species with our project. Another existing solution was Plant Village by Hughes et al. In their research paper. And well, these were over 70,000 images of diseased plants and normal plants as well. But this was just a data set. You couldn't go on and make inferences from this. This was just a data set of images. Another two works which I'd like to existing works which I'd like to draw your interest towards were a plant disease detector by Ramesh et al. And some other disease detectors of which you'll find multiple research studies on. And we found out that most of them end up giving us unsatisfactory performance to work in real life or on the ground, or some, if do give satisfactory performance, are not optimized or usable on small devices, which is a really huge thing we wanted to do, since a lot of crop growers might want to use this on small devices with limited network connectivity, or do all of the machine learning on device. So none of the existing research studies were optimized for this. And this is how well our project is different from the existing ones as well. I'll go on and talk a bit about how we built this project. So I'll start off by talking about how we built our machine learning model. And as it always has been, we started by collecting data, which is very much required for any kind of machine learning algorithm. So we ended up training this on more than 100,000 images of real life plant images. Multiple of them were from online databases or from current online data sets, or some of them even taken on the ground itself. So all of these were so here I just show images of a couple of iconic images. So while collecting images for machine learning, usually we split images as two kinds, right? Iconic images and non-iconic images. So the ones I show on the screen are just iconic images, a large chunk of the data set we trained our images on, but quite a few images were also non-iconic images, which we trained our model on. So we started by collecting data and had over 100,000 images to train our machine learning model on. We'll also soon talk about how we keep improving our machine learning model, which I think is really important, since new diseases might come up in the market, or probably new symptoms for an existing disease might come up. So it's very important to update this machine learning model or retrain this machine learning model in some way. We'll also soon talk about that. But this is how we started. We then started experimenting with multiple architectures and hyperparameters. This was primarily done with TensorFlow, and we heavily made use of Azure on the way. We made use of Azure ML to manage and monitor our project, monitor searching for multiple hyperparameters or searching for multiple architectures. Azure ML was really in handy, which is what we used for building the model, TensorFlow and Azure ML. And then we ended up with a modified version of MobileNet, which was specifically designed for our cause. I'll not go into the details of how and why we modified MobileNet, but our main goal was to a couple of our main goals. To rephrase what I'm just saying, a couple of our main goals were to not just obtain good performance from the model, but it was also that the model should be easily compressible to run on a small mobile device which does not have a lot of compute, because all of this model has to run on the mobile device itself, not on some server through an API call, because as it turns out, a lot of farmers don't have the best network connectivity. So we wanted to not only get good performance, but run all of the model on the mobile device itself. So likewise, according to our data and scenarios, we ended up creating our own architecture, a modified version of MobileNet. Then we also optimized the model to run on device. So as we were talking about, our project is essentially a PWA, a progressive web app. You can also use it offline, and the machine learning model would be running on device. No network calls needed, and any of that jazz. So all of the model was also optimized, and we did multiple kinds of optimizations like folding multiple layers or fusing multiple layers. And we primarily made use of Grappler, which is a great tool to help us do some pretty standard optimization procedures for very large models. But we also ended up creating some of our own optimization procedures to allow the model to run on device. And finally, what I'm also proud about was at the end, this model was optimized to just be 12 MBs in size, which I think is quite small. And wait till you see how long this model takes to do a single prediction in a mobile device. So yeah, that is super small. And the model at the end was optimized to be just 12 MBs. And we'll soon show you how well this model works, especially for small mobile devices with limited network access. And because and on the web part, what we do is we also load this model through multiple network calls, not through a single network call, and through which we end up pretty much caching all of the model for next calls. So you can see all of the models are cached. This is just a screenshot of the background processes happening to show you how it works around. And this is how fast the model was able to make a single prediction on a low-end mobile device. If you see, this is not even 100 milliseconds, which is how fast the model was able to make predictions. We also wanted to make sure the model is able to not only run on device on a small mobile phone, but it's also able to make fast predictions, which, as it turns out, is a really important factor if crop growers are supposed to use this on a daily basis. We want crop growers to use this on a daily basis. So we also had to make sure that our model could inference very fast, could load very fast. And with the optimizations, you can see a screenshot. It barely takes 100 milliseconds to run a single inference, which I think is pretty good. Then we also worked on building the web app. And Rucha, would you like to tell us all about how you built the web app?
Sure. So the entire application that you saw in the demonstration is built around React.js, which is one of the very widely used JavaScript framework these days. And the deployment basically is all done on Azure. So I'll quickly talk about what all our app includes. So as you have already known, our app is a PWA, which is PWA basically gives you all the benefits of a website and an app, just more faster and more reliable, also sometimes more engaging version of your website. Also, the TFJS model that you learned about very recently from Rishit is very optimized. And how we do that is just the way that we individually fetch data flow, graphs and weights, and we normalize the images up to a certain extent, just because our model is trained over 87,000 images plus some augmented images, which is huge. So we need to normalize the images and resize with the nearest neighbor interpolation. Now, these all together help us to make the model very optimized, quick, and energy efficient. So now, the deployment, as I said, is done on Azure. So we're very excited to run our model on the client side, since the ability to run deep networks on personal mobile devices improves the user experience. Hosting the web app we built was quite easy for us using Azure Static Web Apps. This allowed us to set up a CI/CD pipeline very easily, and staging slots with GitHub Actions was, again, the very smooth part for it. So with Azure Static Web Apps, the static assets were separated from a traditional web server, and instead of being served from geographically distributed points around the world, the distribution actually, which Azure Static Web Apps provides, made the entire thing very fast, and it was actually made easier and energy efficient, as I said. So that is how we deployed our app. Now let's quickly talk a little bit more about what are the business plans, how interesting that is. Because since we are already in the beta testing phase, business plans is something that we really care about. So farmers, as we say, don't get charged at all through our app. So, well, how does it work then? Interesting. So because we also provide a pane where crop growers can see potential ways to solve the disease, we would allow plant product companies to place ads, which would pretty much mean that direct source of marketing could be done for them through our apps. The next thing could be, the data which we collect our app generates could be shared with some companies, such as the field sizes, the crop grown in some areas, the materials used for curing some of the diseases or something like that could be shared with some product companies, and which could be used by them as well as it could be used by us to solve many problems in farming domain, such as what percentage of fields diseases have been occurred or have been investigated or something like that, and so on. So this is how we generate our revenue, and that's what the business plan for this app currently looks like. So Rishit, would you like to talk about the impact that our app has had so far?
Sure. So finally, we also, because we want to detect plant diseases, and as I said earlier, it's really important to improve the machine learning model. So we also use plant images anonymously in real time to improve the machine learning algorithm. In part, we do this by a pseudo-federated learning algorithm and try to improve our machine learning model. And finally, that's all about our presentation. And this project was also featured on Microsoft blog and Microsoft's YouTube channel. So feel free to take a look at any of those if you want to know a bit more about what our project does or how we built it, and all about the Microsoft Learn Student Ambassador program and this project. Feel free to take a look at the Microsoft blog and YouTube. I'll put a link to this presentation on chat. And with that, that was all about the presentation and all about our project showcase. Thanks.
Yes, thank you so much. Oh my goodness, your project was so exciting. I was literally navigating to the blog and the YouTube during your conference, like during the talk. So I was so impressed. I absolutely loved the business plan at the end and the impact. Congratulations. We have one question for you, and that is, so of course, during your talk, I navigated to your GitHub page for your project and saw that you're looking for contributors or open to contributors. And so in what ways can our audience right now contribute to your project or just help grow their skills in this space?
I would love to take this up, and probably Rishabh and Richa could add something. So at the moment, I think we would really be working on trying to make the website more inclusive to everyone. Our website currently is only in English, and well, if you're addressing the Indian community for which this was originally built, India has over 30 languages, and making the website more inclusive, more accessible to everyone is our major goal. So we are definitely looking for contributors to help us with more of this stuff.
Awesome.
That is amazing. A call to action to our audience. Oh my goodness. I wish I knew another language because I would contribute. Awesome. Well, thank you so much for hopping onto the Global AI Student Conference today. We appreciate you. It was an amazing talk. I'm so excited to follow the project. And so now we have our next speakers. So I'm going to be introducing Shreyan and Meghana next. And so they are both